u equals x squared plus 2xy plus y w squared. So totally we have three variables here, x, y, and w, right? And we have two constraints, 2x plus y plus w squared equals 24, x plus w equals 8. So the first thing, we just put down the Lagrangian function, and we say we have x, y, and w. Okay? And which would be the first thing? Just pull the utility function here. So x squared plus 2xy plus yw squared. This is our objective function. Plus, now we have two constraints. So we would have two Lagrange multiplier, lambda 1 and lambda 2. Okay, so lambda 1 corresponds to the first budget constraint, and put the resource in the first place. Minus 2x minus y minus w squared. So don't forget to put the resource in the first place. Plus lambda 2, and we put a in the first place, minus x minus w. So this is the whole Lagrangian function. And now we have 5 variables, so we have 5 first order conditions. Okay? So Lagrange lambda 1, 24 minus 2x minus y minus w squared equals 0. The first order condition. Lagrange lambda 2. Oh, sorry. Oh yes. Because we have lambda 1 here only. And lambda 2 equals 8 minus x minus w equals 0. And then Lagrange x. So the differentiation would be 2x plus 2y minus 2 lambda 1 minus lambda 2 equals 0. Is that clear? So can everyone do this? Okay? Lagrange y would be 2x plus w squared minus lambda 1 equals 0. Lagrange w would be 2yw minus 2w lambda 1 minus lambda 2. Alright? And solve. Do you think it's difficult to solve the system of equations? Kind of. Let me show you how to do that. It's actually, there is no definite way to do this. Just look at them, and which one was the simplest one? I would say the second first order condition. Okay? So let me do something like x equals 8 minus w, and replace it back into somewhere. Let me see, maybe the first one. So y would be 24 minus 2 and minus 8 w minus w squared. Is that right? So it would be 8 plus 2w minus w squared. This would be y. So x can be shown in a form or can be defined as a function of w, and y is a function of w. And we have already used these two first order conditions, and what about the fourth one? So what about lambda 1? Lambda 1 would be 2x plus w squared, which would be 16 minus 2w plus w squared. Okay? This would be lambda 1. What about lambda 2? So lambda 2 equals 2y. What is y? (2yw) minus 2w lambda 1. This would be lambda 2. And 16 plus 4w minus 32w. So it will be minus 28w. Oh, sorry, I do something wrong. Something is wrong. 16w with minus 32w, so we have a negative 16w. And 4w squared, don't forget we have a w here, 4w squared plus 4w squared, so it would be 8w squared. And minus 2w cubed minus 2w cubed. It would be minus 4w cubed. Okay? And there's something we have not utilized, this one, the third one. So we may use the third one to solve this. So 2x, what is x? A minus w plus 2y plus 2y, 8 plus 2w minus w squared and minus 2 lambda 1. Lambda 1 would be 16 minus 2w plus w squared and minus lambda 2. Minus lambda 2 would be negative 16w plus 8w squared minus 4w cubed equals 0. Okay? So, 16, so 32 minus 2w plus 4w plus 4w. Oh, sorry, something wrong again. Once again, 16 and minus 32, so there's no constant term, right? And negative 2w plus 4w, it will be positive 2w plus 4w, 6w plus 16, it will be 22w. Is that right? 2, 4, 6, 22, yes. And what about w squared? Minus 2, minus 2, minus 4, minus a. So it's a negative 12w squared. And the last one, w cubed minus 2 plus 4. So it's plus 2 cubed. And let's do something like 2w and w squared minus 6w and what then? 11. And something we can do about this. When you are in senior high school, you have already learned the formula to solve this, right? W equals so this would be a complex number because you will see a negative value with a square root. There is a I. Remember that? It's an imaginary part, and the real part is imaginary part. So this would be a complex number. It's not a real number. So we have three solutions for W. 0 and 6 plus minus the square root of negative 8 divided by 2. So we don't have to consider these two solutions. Is that right? Okay? Now we have W star, the optimal value or the critical value. W star equals 0, and then what about X star? X star would be 8. And what about Y? The W is 0, 0, 8. And what about lambda 1? 0, 0, 16. And what about lambda 2? 0. So the critical value of X, Y, W, lambda 1, lambda 2 would be 8, 8, 0, 16, 0. 8, 8, 0, 16, 0. Looks like complicated, but actually you need something. We call it patience. If you've got patience and you do this very carefully, really carefully, then you may solve this. And also with some knowledge you've learned in your high school level about how to solve the roots. Okay? So any question here? Oh, I forgot to use the microphone. Okay, so all you need is patience. And the next one, the objective function would be x, y, z, w. Is a 4-variable function. And there is only one constraint, x plus y plus z plus w equals 4. So the Lagrangian function is quite simple. Put the objective function here plus a multiplier with the resource in the very first place. Minus x minus y minus z minus w. Okay? So the Lagrangian function, you must be able to specify or to put down. Without this, you cannot do something further, okay? So this would be the basic thing you must learn. Without this, you may got 0 points next week. Actually not 0 point, but you will lose a lot of points. Okay, so this would be the basic thing you need to learn. Put down the Lagrangian function. And then we have how many first order conditions? We have x, y, z, w, and lambda 1. So we have totally 5 variables. So lambda, not lambda 1, lambda. So the differentiation with respect to lambda would be 4 minus x minus y minus z minus w equals 0. And we set it be 0. Differentiate Lagrange with respect to x partially, okay? So we got the first term would be y z w and minus lambda equals 0. And differentiate with respect to y, x z w minus lambda. Lagrange z x y w minus lambda. With respect to w would be x y z minus lambda. Okay? So with these two equations, when lambda equals to lambda, so x y w equals x y z, so z equals w, right? From the fourth and fifth first order condition, we have z equals w. But you got to notice something, that sy cannot be 0, right? You need this premise. You know why? ax equals bx. Can you just conclude that a equals b directly? You need a premise or an assumption that s cannot be 0. If x is 0, then anything multiplied by 0 would be 0. 0 equals 0, right? So s cannot be 0. That is why we got this. So the same thing, we cannot xy equals 0. And from these two, we will see something as z equals y. Z equals y, and the premise would be xw cannot be 0. And then from these two, we have what? X equals y. X equals y. With the premise of zw cannot be 0. Okay? So from here, x equals y equals z equals w. Therefore, utilize the first order condition would be 4 equals 4x, then x star would be 1, and y star, w star, z star, and what about lambda? Lambda equals 1. Lambda star. Okay? So this would be the critical value. 1, 1, 1, 1, 1. And what about if something, for example, x equals 0. If x equals 0, so we cannot have this, we cannot have this, but if zw are not 0, then we may have x equals y, right? And x is 0, y is 0. And lambda will be 0. Lambda will be 0, x 0, x 0, 0, 0. Okay? So 0, 0, and zw, let me see. Can z and w be 2 if they share 4 equally? So 0, 2, 2 minus 0 equals 0, yes, right? And so there would be infinitely many solutions here, actually. And 0, 2, 2 equals 0. 0, 0, 2 minus 0 equals 0. 0, 0, 2 minus 0 equals 0. Okay, so all 5 first order conditions are satisfied if we assume that. So there will be another solution x, y, z, w, z, lambda. It would be 0, 0, say 2, 2, 0, or 0, 0, 3, 1, 0 is fine if the sum of w and z equals 4. But later on, you will see something about the matrix. All these kind of solutions cannot be maximum or minimum. And because I have no time to introduce to you the second order condition here, because it would be a 5 by 5 matrix, a 5 by 5 matrix, 5 rows, 5 columns, that big matrix, and we need to compute something. And actually it's not very difficult, but quite easy to find they will not be critical, although they are critical values, but they correspond to something just like the center point or the inflection point. It would not be a maximum or minimum. So since we are maximizing our utility function, then this kind of solutions, we just ignore them. Alright, the meaningful solution would be this only. Alright? You don't have to worry about how to solve this. All you need is to learn how to put down the Lagrangian function and put down the corresponding first order conditions. That's fine. That will be fine. Okay? Alright. Let's go back to a general case. This would be a general case. Okay, now our objective function would be utility function, u of q1 and q2. The quantity of good 1 and good 2. And subject to P1, the price of Q1, of X1. P1, Q1, the expense on good 1, plus P2, Q2, the expense on good 2, less or equal to. But since we are maximize the utility, so it would be an equal sign here, equals our income. Whenever you see the problem specified like this, and the first thing would be put down the objective function q1, q2, okay, plus a lambda, and then what is it? What should I put in the first place? The resource. Now, what is the resource? Y. Y minus P1, Q1 minus P2, Q2. Okay? This would be the Lagrangian function. So this is the very first thing, the most basic thing you have learned. Okay? And then, now we have three variables, Q1, Q2, and lambda. Q1, Q2, and lambda, we call them as endogenous variable. Endogenous. variables. In Chinese, it would be 内生变数, okay? And y, p1, p2 are something we call them exogenous variable. In Chinese, translated by 外生变数, okay? The reason why we call these three variables as exogenous is because they are external to the model. That is something we cannot decide. So y, how much income do we have? P1, the price of good wine. We are just a single consumer. We cannot affect the market. Okay? So the price, we are price taker. We cannot decide the price. We cannot decide the price of good 2, P2. So these three things are something the goose, or my goose, decided for us. So we are facing an environment with these variables. And the only thing we can do is to decide which levels of Q1, Q2, and lambda we want to choose so that we may maximize our utility, okay? So we want to maximize our utility. So we differentiate Lagrangian function with the endogenous variables. The first, with lambda, it would be y minus p1, q1, minus p2, q2, set at b0. And this exactly, precisely, the budget constraint. And Lagrange 1 would be u1, the marginal utility of good 1, minus lambda p1 equals 0. Okay? And Lagrange 2 equals u2 minus lambda p2 equals 0. And then I would introduce something very important here. So listen to me really carefully, please. With the second and third first order condition, we may have this relationship. But why? MRS equals MRT. Again, we see this, right? The last time we saw MRS equals MRT is something like on the diagram, right? So this points, this MRS is actually the slope for the indifference curve, MRS. And MRT is the slope of the budget constraint. Remember that? Okay, now again, from the math, why we see MRS equals MRT? Because if we rearrange this equation, we put lambda P1 to the right-hand side, put lambda P2 to the right-hand side, and divided these two equations. The left-hand side would be U1 to U2, and the right-hand side would be lambda P1, lambda P2, right? And lambda can be cancelled. So it would be P1, P2. All right? And if you put a negative sign here, put a negative sign, then this would be MRS, and this would be MRT. Do you remember this? Okay? So either from the diagram or from the math, the first order conditions, you will see the equilibrium condition or the optimal condition. So your optimal solution would be MRS must satisfy MRS equals MRT, this condition. And you will see what? From another